Well, hello everybody, and welcome to a new video where we're going to talk about C++, Introduction to C++. In this video, we're going to talk about functions, and functions in C++ is a kind of really big deal. So we will have multiple videos when it comes to functions. But for our class today, we're going to talk about the top-down design. We're going to talk about predefined functions. We're going to talk about a user-defined functions. We're going to talk about the procedural abstractions, and we're going to talk about local variables. So let's start with the top-down design. What is a top-down design? Well, it's not a syntax, or it's not a tool that you're going to use when you write a code. It's basically a concept in programming. And the idea here is very simple. When you have a big project, it's not a good idea to treat this big project as one unit. You basically, and it will be a lot better if you can bring this big project and break it down into a smaller tasks. And that's basically what we mean by top-down designer. So when you have a big problem, a complicated problem that needs a solution, instead of looking at this problem as one unit of multiple steps, basically try to break this big complicated project into a smaller tasks and dedicate your energy and your knowledge to design that step and make it work perfectly fine, and then you move to the next procedure or next step, and you keep going in that way. So that's basically what we mean by top-down design. Now, top-down design has a lot of benefits. Well, I'll give you some of them. Basically, if I give you a code that contains millions of steps all in one unit, and I tell you, well, there are some problems and try to fix them, it's going to be really hard for you to do that. But if I break this million line of code project into groups of tasks, and when I tell you there's a problem in one of those tasks, you basically don't have to worry about the other parts of the project. You just go and fix that small piece of it. And the same thing when it comes to testing. When you try to test your code, all you have to do, instead of thinking about how do I test the whole project as one unit, test each one of those procedures one by one and see if you get the right results. Also, it's a really easy when it comes to teamwork. So, for example, if I have a complicated project that I know can divide this complicated project into 5 different smaller projects that work together to get the original complicated one fixed, I can divide this project for 5 or 10 people, and each one of them is going to work independently from the others, and he's just going to focus on that main smaller problem that he has to worry about, and then everybody will give their solution back to me as a manager, and I'll just put them all together. It's also easier to write, and it's easier to update, and it's easier to understand. Like, I give you 100 line of code and I tell you to understand it, and I give you 5 lines of code and I tell you to understand it. Of course, the shorter the number of lines, the easier it will be to understand. So this is basically what we mean by top-down design, and the tool that we're going to use in top-down design is basically functions. Now, functions in general are categorized into 2 main categories: a program-defined or a user-defined functions, and a system-defined functions. We're going to start with a system-defined function. What is a system-defined function? That's basically what we're going to be talking about next. Functions, before I start talking about how do we create functions, I just want to let you have an idea that what is a function itself. A function is basically a block of code that is designed to complete a very specific task. So a function by itself, it's not a solution for a whole project, but it could be a very, very small task in that project, or a little bit more complicated task in that project that you can use. I'll give you one example here so you'll understand here. You see the cout, for example. Well, this cout is not a really exact example, but I just want you to think about a cout as a function. Now, I want to show something on the screen. Now, the complication that you have to think about whenever you want to get something like that done, it's really, really big deal, and it's not easy. But This people who created C++ realized that a lot of people are going to actually try to show something on the screen. So basically they created that code for you and they gave it to you and they told you, here it is. If you want to show something on the screen, just type cout and use this syntax and you'll be able to see the result on the screen. Now, what is behind the cout? It's hundreds of lines of code that you don't see. Your job basically is just to learn how to use the cout. So that's it's not exactly a function, but it's a concept here. The idea is very similar. Now, let me ask you a question. If I ask you to show me the square root of a number, for example, 81, what is the square root of 81? It's 9. Now, but if I ask you to show me that on the screen, how can I make the computer here calculate the square root for a number? Well, I have no idea, but here it is. I know the square root of 81 is 9. But again, what if I wanted my computer to show me the square root of a number? Well, the idea here is to use what we call a system predefined functions. And to do that, in a lot of cases, those functions that you're going to use are defined inside what we call header files. You see this IO stream here. Basically, the cout and the cin here and the get character and the end line are all defined here. If I take this away, my compiler is going to complain and he will say, I have no idea what are those. So the cin, the cout, the end line, the get character, all of them are defined inside the IO stream. So whenever you want to use a system predefined function, you need to include the header file. Now, what header file? Well, every group of functions are defined in a specific header file. And the first one I'm going to show you now is what we call the cmath. So if I come here and say include cmath, and there's a huge library of header files that we can use, but again, you don't have to memorize them all. We're just going to go and as we move on with time, and I'm going to show you a lot of them. So a cmath basically includes a lot of functions that will just show you some math operations that will be done. For example, if I come here and say double, and I will call it num, and I will say sqrt, which is a shortcut for a square root, and I'll put 81 here, put semicolon, and now if I come here and say cout, and I'll just type num and line, and let me take this cin away. I don't need it for now because I'm not doing any input operation. And here we go. We got 9. Let me put a value like this. And here we go. That's the square root of it. So again, this is just an example. We do have a lot of methods inside this cmath. I'm just showing you one of them. If you just go ahead and Google cmath, it will show you all the functions that you have in this library here. Now, the question is, why do we need those libraries? Because it's just going to make your life a lot easier. Think about this. Every time you want to do the simplest arithmetic or mathematic operations, and you have to write a code for it, a very simple project will take years to be done. And instead of that, try to look and see what is available for you and just learn how to use it. And that's basically what we mean by a system defined functions. So the function, as you can see here, there are some syntax that you should know about it before you start using it. Those details are explained to you usually in the library documentation. But every single function has a name. You call it by its name. So here we go, sqrt, that's the name. Now, this here, what we call parameter, argument, sorry. Argument is basically a number that you're going to use with the function to get something back. And some function basically will return something, sometimes you will not return anything. In this case, this will return the square root of whatever you're going to pass here. So this is what we call an argument. So it's very important to understand that. Let me just show you another example. Double. Let's call this one num2. Let's go ahead and change this one to be num1 and num2. And I will say POW. And I will put, for example, 2 to the power of 5. And put semicolon here. And this is num1, sorry. Now let me copy this and put it down. Now, can you guess what POW is used for? It's power. So what I'm doing here, this is 2 to the power of 5, which I believe should be 32. And here we go, 32. So as I said, there is a huge library of functions. You can Google it, you can have a look at it, and then not just CMath, there's a lot of other header files that you can actually include in your file. So bottom line, every time you think about doing something in your computer program, ask yourself this question: have anybody done this before or not? If the answer is yes, save yourself time and work, and just go ahead and learn how do you use other people's work into your code so you can focus on your main problem. And the syntax for being able to use those functions, again, you have to include the header file, you have to know the name of the function, that's rule number 2. You have to know the argument that you're going to pass. Now when it comes to arguments, you have to know how many arguments. You see here, I got 1 here, I got 2, and when you pass argument, what kind of data type you're passing here. Again, is it a character? Is it a string? Is it a double? You have to also make sure that you know that. And also, you need to understand what will be returned back after the calculation. This will return the square root. This is going to return 2 to the power of 5. And there's a huge library of functions. I'll show you a third one here. Let me just copy this. Control C, and I'll put here. And this time I'm going to go ahead and use ABS, absolute value. And again here, absolute value except only one parameter, argument, sorry. And I'm putting a negative value. You would notice it's going to return a positive value. And here we go. So this is basically what we mean by predefined functions. There are a lot of other header files. I'm going to go ahead and try to explain some of them right now. And then after that, we're going to start talking about how do we create our own. Now, there is one of the basic tasks that's required in programming is how do we generate random numbers? How can I make my computer generate random numbers? So to do that, we basically need to include 2 header files for that. And the first one, let me just write them here, include CSTDLIB, and another include here is what we call a ctime. Now, I want you to pay attention to those 3 ones. It's a C math, CSTDLib, and ctime. Well, those header files basically originally were generated for C programming language. And for C++, they just added the C character to it. So if you're going to learn C maybe in the future, for any reason, you will notice that you have the same exact libraries that you have here in C++, except that you will not see the C character here. Okay, so how do I generate a random number? Well, number 1, and this is very important, you have to type this command here, srand. And then after that, you have to this is going to be the argument, time of 0. So what am I doing here basically? I'm asking the compiler to go ahead and check what is the seconds or the milliseconds at this moment. And that's how you can guarantee that you will get a random value, because if I take this out, every time I ask the compiler to generate a random value, it's going to be the exact same number. But again, I'm including the time as a parameter in the calculation for that random value, so that will guarantee that every time I run the program, it's going to show me a different value. Now, right after that, let's go ahead and create a double here. Now we'll call it call it R. And to create a random value, all I have to do is just type RAND. Oops, where am I typing? I can't see it. Okay, here. RAND, and you put a parenthesis and you close it, and this will guarantee that you'll get a random value. Now I'm going to run multiple times, and you will see that every time it's going to run, it's going to show me a different value. Oops, sorry, I didn't print it out, so let's go ahead and do that. R and line. Let me run it again. And as you can see here, I got this big number, 27136. Let me run it again. 27172. Let me run it again. Come on. 27208. So you can see here that every time I run it, it gives me those big random values. Well, the question is, what if I want to control the range of the values that's supposed to be printed? Let's start with this. You can have the number 0 if you want. Like randomly, that's a possibility to get the number 0. But let's say I don't want 0. I want my program to generate a number in the range 1 to 100. So what I do basically, I put 1 here plus, you open a parenthesis here, and you go here and you type percentage. This is a modulo operation, and you close it. Now this way you can guarantee that it will give you a value between 1 and 100. Now remember, this is very important that when you, since I'm modulating it with 100, the max is going to be 99. So it could be 0 to 99. I'm adding 1 to it, so it's going to be 1 to 100. Now if I want to create a dice game, well, just put 6 here. So I guess you can understand. Now this is very important. You're going to have to use this a lot in the future. Let me run it, and you'll see that I got 60. Let me run it again. Come on. My super fast computer, I got 96, and you can tell these. Now let me just take this away and try to run it again. And you got 42. Okay, 42. That's acceptable. Let's run it again. And let's see here. What do I'm going to get? And here we go, 42 again. Let me run it for the 3rd time. Come on. And 42 again. So you see that every time I run, it's generating the same number. So it's not random anymore. It's random when it was generated the first time, but when you repeat the program, it's not going to. So I need to include the time as an element in this calculation. So every time you run the program, it's basically going to generate a random value. So this is basically how we generate random values. What can we do to here? Let me see here. I don't want my thoughts to be lost somewhere. Okay, so that's basically how we do the calculation for random values. Now, there's something in C++ that I don't think I mentioned before. It's called casting. Casting basically means you're changing the data type. I think I did mention that before. There are 2 ways of casting, and one of them is to just basically write the data type in front of the number, and that's the old fashion of casting. But there's another way to do casting, which is recommended. I'm just going to show you an example for casting here. Let's just go ahead and type casting examples. So I'm going to create an integer, and I'm going to call it x1. And here's what I'm going to do. I'm going to say static underscore cast. And I'm going to put, well, you know what? Let's just change it. I'm trying to change it to an integer. And in this area, you type a number like 12 point something like that. This is basically changing this number to be static at once. But again, this is not how we do it, but I'm just showing you the syntax for it. And of course I can come here and change this to be a double, and come here and change this to be a double, and I have to put here an integer if I want to. So it's going to cast this and change it. Well, this I can come here and type, let's go back to the integer, and here I'm going to put num1. So num1, whatever is going to be returned here, is going to be cast to be an integer x. Now remember, since I'm actually assigning it to x, so x basically is going to have that value. But if I want to use num1 as a static, at one time I can copy this and just put it here, and that will convert it to a cast. Of course, I have to put num1 between parentheses. So that's new school of casting, if you will. I just thought about mentioning it here. Of course, I can do the same thing, integer x2 equal, and you come here and you type integer, and you open and you put num1 if you want, and let's put num1 here as well. So these are two ways for casting. Okay, so this basically will summarize everything about user-defined function. Next, we're going to be talking about, this is basically summarize everything about the system-defined functions. Next, we're going to talk about user-defined functions, and this is basically where you have to pay special attention. Okay, so let's move on to a user-defined function. Now, as you can see here, this and this and this and this, those are all functions that's defined by the system. Now the question is, how can you as a user define your own version of a function? Well, the details are a lot to worry about. So let's go ahead and think about that and talk about it. Number one, you need to define your function to be able to use it. Here, I'm using it, but it was predefined by the system, so I didn't have to worry about that. But since you're creating your own function, you have to define it first, and then you can use it. You need to, at least at this moment, you need to define your function before your main function here. Before you get into the main, it has to be defined. Usually, we keep it between those header files and the usings for the stds and the integer functions. This is basically where we create the function. Now, the function itself contains mainly two elements. The first element is what we call the head of the function or the signature of the function, and then we have the body of the function. So if I want to imagine that this here is the head of the function, it's going to be followed by the body of the function, which basically is it starts with the curly brace and it ends with the close of the curly brace. Now we're going to talk about the body of the function later, but let's talk about the signature of the function. The signature of the function contains a lot of elements. So let's start with the first one. At the beginning, and at this moment specifically, because later on we're going to see we're going to add a lot more to it, we need to specify by the end of the execution of this function, what am I going to get back? Now, some functions return something and some functions doesn't return anything. So if your function is not returning anything, you type void as I'm getting nothing back. Right after that, you have to tell me what is the name of the function. And now remember, the name of the function follows the same rules that you know about naming the variables. So my function, I'm going to call it my function, for example. So you define what's going to be returned, you define the ID, and then after that you have a curly brace and you close it. And in this area, you have to tell me, what am I supposed to receive from the user when he actually call the function? And for example, my function is going to receive, let's say, a character, and I'm going to call it C. So this here represent the body, the signature of the function, and this is the body, which is empty. Now look what I'm going to do. I'm just going to have C out the past character is, and I'll put C and line, semicolon. I missed something here, and that's it. So this is a very, very simple function. Just remember the syntax. This is the body, which basically could contain multiple lines. This case is just one line. This is basically what we call the parameters, and this is what we call the name of the function, and this is the return data type. Now, if I want to use this function, how do I do that? First of all, I'm going to go inside the main function, and I'm going to come here and do this. Since it's not returning anything, I can just come here and say my fun, and I'll pass A, for example. Now let me run it. You know what? Let me call it multiple times. One time I'm going to pass A, the other time I'm going to pass Z, uppercase Z. Now if I run it, you'll notice that the pass character is A, the pass character is Z. So this here, a very, very simple demonstration of how do we create a function and how do we invoke it or calling it. And this is it. Now remember, this is extremely important. This here, if your function is going to return something, then you have to tell me what is it going to return? Is it going to return a double or an integer or a character or a boolean? What exactly is going to return? And this is the name. The name should match, you should follow the rules that you know about variables when you call your function, and it's better to give it a name that represents what it is. And now you can have a single character, you can have multiple you can have single parameter, or you can have multiple parameters. This case I have one. Sometimes you got nothing. So it depends on the function itself if you're going to pass anything to it or not. Now this time I'm passing 1. I'm showing something on the screen. Since there is no return, something is coming back, I'll just put a void function, and that's basically how it works. Let's go ahead and have a different example. Well, before I get to the different example, one thing you should know. You see this A here? A is going to be passed to the function here as a copy. So if you want to think about this, just because later on we're going to talk about more detailed versions of functions. But for now, imagine A here by itself, it's a document. And you want to give that document to someone to process it. Passing that document this way basically means mostly, you can imagine it as you're going to a copy machine, you're making a copy of A, and you're giving it to the function here. So if I decided, for example, to say C equal, and I'll put R. So as you can see here, C is changed now to equal R. I passed it as A, but I decided to change it to R. You should know this A here will not get affected by whatever change is applied here. Why? Because just like if I give you a copy of the document and you decided to burn your copy, that doesn't mean my original copy will get affected by that burning and it's going to be burned too. No, that's in the magical word. Here, I give you a copy. You burned your copy. You did whatever you want to do with your copy. Your copy is going to be affected by that, not the original one. Let me take that away. Okay, let's go ahead and create another function. This time, I'm going to create a function that will add two numbers together. So I'm going to add two integers. Let's just be specific with that. So to do that, let's create a function for that. I will call it add. And then since I'm adding two numbers, then I have to pass two numbers. I'll put n1 here, integer, and 2 here. And I'll put a parenthesis and you close it. Now, this is missing something, which is the return data type. So since I'm adding two numbers, the result of adding two numbers, integers, are actually an integer. So I'm going to come here and type an integer. So this is again my signature or my header of the function. Now, if I want to do it here, I'm going to come here and say integer result equal n1 plus n2. And then this is important, return result. So here we go. This is my function. And this function basically is going to receive two integers. It's going to add them together, assign it to results, and then return the results. Now, I want you to pay attention to this. This void function here, when I called it, I just called it like that. When I want to do this add function, this is not going to work the same. If I put 10 and 20, well, I'm passing 10, I'm passing 20. 10 and 20 are going to be added together. I'll get the result 30. 30 is going to be returned back here. But what am I doing with 30? Nothing. So I have to figure out what am I going to do with the 30. Unlike the void function, since it's not returning anything, then just keep it as it is. But if you have a function that is returning something, then you have to decide what are you going to do with the 30. Well, basically you have two options. You can show it on the screen by a very simple cout end line. But you just have to remember that if you do it this way, it's going to be shown on the screen and you're going to lose it. You're not going to be able to use it again. Or you can come here and say an integer, let's say num, how many nums do we have up there? 3, 4 equal add, and I'll pass this time 20 and 30. Put semicolon. Now if I say cout num4 and line, you would notice that num4 is going to hold the value of the summation of those two. And if I want to go ahead and use it somewhere else in the program, I can actually do that. So let's give this a try. And here we go, 30 and 50. And this is me basically creating my my versions of functions, my fun and add functions. And again, as you can see here, it's a little bit simple. You just have to pay attention to the syntax, and you have those, most of those things that I explained here are decisions that you have to make as a programmer. In a lot of cases, you're the one who's going to create the function. So you have to decide what's going to be returned, what am I going to call it, how many parameters I'm going to be passing, and what are the data type of these parameters, and what exactly is supposed to be done in this area. So this is basically what a user-defined function. In reality, those are not, functions like this do not exist. Basically, they should be a lot more complicated than what you see here. And usually what we do, we like to come at the beginning of each function and just explain what is this function. Add function, add two integers, and return the results. Why is this important? Because sometimes some people will see the add and look here and they will have some sort of difficulties understanding what's going on here. So you need to give them some sort of an explanation about what is this add function is doing. Okay, so let's keep going and let's see if there is anything that we have to worry about when it comes to functions. Yes. Rules you have to understand here, and I'm going to do something here. I'm going to put a double instead of an integer. Now, as you can see here, he's complaining about something. Well, he should not. Yeah, it's gone. Now, the order of the variables are extremely important. So let's just imagine I have something like this. 10.12 and 20 passed to the add function. Remember, 10.12, which is a double because it has a decimal point, will be passed to n1, which is an integer. So the order is extremely important. There's a lot of other programming languages, no, the order is not important, but with C++, yes, the order is important. You want whatever you're passing to match the data type. That would be number one. Number three, and this is very important also, the number of arguments that you're passing here. See, immediately you got an error because, well, you're passing 10 and 20. I understand that I have 10 and 20, but what am I supposed to do with the 50? That's something that you have to pay attention to as well. So this is basically what functions, and this is how it works. Now, before I can move on to the next topic, there are a few some details you would like to add to your function understanding here. Number one, this here will work perfectly fine, but I want you to imagine instead of having 2 lines of code, we have 500. That basically means your code is going to be very, very long at the beginning before you get to the main function. Now, as a programmer, you need to go ahead and start from the main function to understand what's going on. But for the compiler, it's extremely important for the compiler to have the functions declared and defined before the main function. So we are in a sort of problem here. So here's what we can do, and I want you to pay attention to this. I can cut this from here and move it all the way down. Now immediately we notice that the compiler is going to start complaining if I try to run it, but it's not showing me any errors here. Let me just run it. And here we go. That's what I was talking about. Basically, compiler will tell you, I have no idea what is add here and what is my fun here. So, well, I declared them here, but again, the compiler is moving from the top to the bottom. So he got to, where is it? Fun before he sees the declaration for it here. And that's causing a problem for it. So what do? There's a solution, and that solution is called using prototypes. What is a prototype? Prototype basically means you copy the header of the function and you put it at the top here. And that's basically how we do it. And you have to put a semicolon here. And you do the same thing here for the other function. And you put it here. And you put a semicolon. So how is that any different? Well, basically what's going to happen, when the compiler is going to see a prototype, the compiler will understand, oh, there is a function called myFun, but it's defined at the bottom. So, okay, whenever I need to have my fun, I know where to look for it. And the same thing is going to be applied to the add function. Now, there's an alternative way to create those prototypes. Just tell me what is the data type without actually putting the name of those variables. Just tell me there's a function that has 1 character parameter. There's another function called add that has 2 parameters. The first one is integer, the second one is a double, And since they're prototypes, that basically means the definitions is all the way at the bottom. Okay, so those are my two functions. Let's just go ahead and have an example of a function. Now imagine, and I'm going to come here at this level. Before I do that, let me just run it to show you that it will work with no problems. And here we go. Now imagine that I do have two numbers, integer. Let's go ahead and create y1 equal 10. And then I will create y2 equal 100. Now I want you to think about this. If I would have, it's again, just think about it this way. If, and I'll put my y1 is greater or equal 5, or and y1 is less or equal 10. So I need my value to be between 5 and 10. Or y2 is greater, let me put a value here, 20 for example, is greater or doesn't equal 99. Let's just put it that way. Again, this doesn't make any sense, but I'm just showing you that I do have an expression here. And this is a Boolean expression. Now, what I can do, again, what I'm trying to do, I'm trying to save the user the headache of looking at this expression and trying to understand what's going on. So what I can do, here's what I can do. I can cut this from here. I'm going to come at the top here and create a new function. This time, this function is going to return a Boolean variable. And I will say check. And when I'm going to come here, I'm going to put integer, let's say x integer y. And in this area, I'm going to say if, and in this area, look what I'm going to do. I'm going to come and put my expression, but this time I have to put it as x, and this has to be y. Now, if this condition is true, return true, else return false. Put semicolon here, put semicolon here. Now all I have to do, come back here and type check and pass y1 and y2. So I'm going to go and pass y1 to x and pass y2 to y and test everything in this function, and if it's true, return true, otherwise return false. Now you may ask a question, what is the whole point of that? Why don't you just put the condition here at the bottom? Well, believe me, in artificial intelligence, this expression, Boolean expression, could be like 5 lines code complexity. For example, I want to check if a pixel in an image is a cancer pixel. So I need to do a lot of tests for that pixel to decide if it's cancer or not. So instead of putting everything here every time I want to do the test, which is basically going to be a real long line of code, I will just type cancer and I put the value of the pixel. And then after that, I'm going to test it in that function. And again, if it's a cancer cell, it's going to be returned. If it's not, it's going to return false. And that's how it works. So usually, again, you don't have to do that all the time, but if you notice that your Boolean expression for the if statement, it's getting way too long and it's a little bit more complicated, if I can replace it with one word that's simplified what exactly I'm trying to do here, what I'm trying to check here, that would be a good plus to add to your code and project. I know that the numbers that I'm using here, they don't make any sense, but I'm just focusing on the syntax, not anything else. Okay, so I believe this probably will be the end of the user-defined function. Let me just put something here. Cout true was returned \n semicolon, and let's just go back here and put if it's not, I'll just put else. And let's put false was returned. Copy that, put it here, false was returned. So I'm almost done with the syntax. Now we're going to move on into a little bit details about what is like some details that you need to understand about methods, and there will not be that much of programming in that part. Okay, so the last part that I want to talk about is actually there are two parts I want to talk about. They're really short, so this will not take a long time. The concept of creating those functions that you have to understand, it's what we call abstraction. Now, what does abstraction basically means? Abstraction basically means you are trying to hide details from the users. So what does that mean? Now, let's look, for example, at the square root. As I told you, square root by itself, it's a really long code. But again, me as a user, I don't want to worry about that. All I need to worry about, how do I use your tool? Let me just simplify it for you. If I give you a car and I tell you every time you want to run this car, all you have to do, just get the car, the keys inside, press on a button, and the car will work. You see how simple and easy is that? Now imagine this. Every time I ask you to run the car, I have to explain how all the mechanism parts and electronic parts works, and you have to go and connect them and test them and do them by yourself, which basically going to make just turning a car a really complicated operation, and nobody will want to drive cars anymore. So what are we trying to do here? We are trying to hide those details from users and explain to them how do they use our product in the simplest way. And we do that for two reasons, not because we really care about the user. Well, actually, we do care about the users, and we want to make their life easier. But in a lot of cases, let's just go back to the car example. If that person doesn't understand how cars work and he misconfigured wires trying to make the car works, he may blow up the car itself, which you don't want that to happen. So you want to keep your user away from the details, because he may end up making a lot of more troubles, and it's just going to be more complicated. Nobody would want to buy your product. So your job in a lot of cases is to hide those details. And how do I do that? Just like I did here. My fun. All I have to do is to worry about how do I use the function. What's going on inside my fun, which basically is this one line, could be millions of lines of code. But again, I'm the one who created it. I'm the only one who has to worry about it. But you as a user, you don't have to worry about that. I'll give you an example. You work for a company, and your company basically is making hair for the new PlayStation 5 that's coming. So animation companies and video game companies can use your hair in their characters. Well, your project, let's say, is 500,000 lines of code. Now remember, those 500,000 lines of code, if I want to actually sell that product to some companies, and every time they want to use my code, I have to explain those 5,100 lines of code, then nobody will buy my project, my product. But again, if I just come to them, if you want to use a hair on a head of your character, just type hair and tell me the length of the hair, and tell me the color of the hair, and tell me if there's any style you want to apply to that hair, and you tell me if there's going to be winds or something. Just give them a little bit details and tell them this is how you use the hair. So that's basically what we mean by abstraction. Abstraction basically means hide the details, keep the details for you, the one who created those functions. Why would I want to do that? For two reasons: simplify and make the life of the users a lot easier, so they can actually use your code with no problems, and hide the details. You don't want them to have access to those details, and they may end up ruining your program. And guess what? They're not going to blame themselves. They're going to come back to you, because it's your project after all. So you have to make sure it's 100% protected. That will be the first topic I want to talk about. The second topic, it's basically what we mean by let me just make sure that I get you the right term: local variables and global variables, or the lifetime of variables. We mentioned that before, and I'm going to go in a little bit more details about it. Now, I want you to look at this main function here. This is main function, and there's a variable called num1. Now, as long as I'm inside the main function, I can print m1 anywhere I want. For example, if I come here and type this, num1 and line. Again, it doesn't make any sense that what I'm doing, but again, there's no complication here. The compile is not going to compile about that. Yes, you can use num1 because you declared it here. But let me copy this and try to do it here, for example. and immediately you will get, let me take this away and fix it. Immediately get an error telling me I have no idea what is num1. Of course, because num1 is not declared inside this function. What I'm trying to say here, when you declare a function, when you declare a variable inside a function, then you can only use that variable inside that function. And this is what we mean by local variables. So C here is a local variable. N1 and N2 are local variables. X and Y are local variables, and they are used here. Now, what does local variables mean? Well, let me show you something. I can come here and replace this with N1 and N2. This is extremely important to understand. N1 and 2. Even though I don't like to do it that way, but I'm just going to show you that this is possible. Now, N2, sorry. Now, look at this. So I got N1 here and N2 here, and I got N1 here. Now remember, N1 and N2 are for this function, and N1 and N2 are for this function. Those are two separated N1s and N2s. Just because they share the same name doesn't necessarily mean they are the same variable. Each one of those variables have a lifetime. It's going to be, you can have access to them. This N1 and this N2, you can have access to them here. This N1 and N2, you will have access to them here. So that's something you have to put under consideration. Same thing here. If I take this N1 and I want to actually use it here, I'll get the same error because I'm inside the main function, and N1 and N2 are not defined inside the main function. All these variables that I just mentioned, we call them local variables. Now the question is, what if I want to, what is the opposite of local variable? Well, that's basically what we call a global variable. And I'm going to show you an example of a global variable. If you come here and create an integer, and I will call it my num, and I'll set it to 10. This is basically what we mean a global variable. When you declare your variable outside of the function, so it's not inside the main, it's not inside any of those, it's here. Look what I can do. If I come here, and let me just replace this num3, there will be no compiling error. Why? Because it's global. Everybody will have access to it. So that's one thing. Now let me come back here and replace it, for example, with this one. Still, no problems. Why? Because it's a global variable. You can use it anywhere. Now you may think, oh, this is a relief. I'm creating all my variables to be global variables. No, it's highly not recommended to do that. And there's a lot of reasons. I don't want to make this video a lot longer than it is, but do not use global variables. Avoid using global variables as much as possible, because again, when you have a variable that everybody have access to it, you may end up changing the value at a certain place, and then when you go to another place and use it, you think that you have a specific value for it, but it was changed because everybody have access to it, and that will crush your program. You don't want that to happen. So if I don't want that to happen, why do I have global variables in the starting? Well, I'll show you an example where a global variable will be a really good idea. And look at this. What is this? It's the pi. It's a double. And most importantly, it's a constant. So nobody can change the value. So that will be number one priority. Number two, we know pi. Everybody's using pi. And the pi has this value. And it has been used for years, and the value never changed. So this is a good example of, well, I don't want to have to come here and declare pi and then come here and create pi and come here and create pi if I'm going to use it multiple times. This is a good use for a global variable.